welcome to my talk, Measure and Increase Developer Productivity with the Help of Serverless. So my name is Vadym. I've already been introduced. I will only want to add that I'm currently the part of AWS Community Builders Program, so just exciting times ahead. And yes, I'm working for the company called ip.labs, and just what we are doing is writing software for editing and purchasing of the photo products like calendars, photo books, prints, posters, so everywhere where you can print the photo. And we are dealing with AWS Cloud for more than 3 years, and we are very active in the serverless space. So a lot of things which we develop from the scratch will be built with serverless first mindset. Just before we will start talking about serverless and how it can help us increase the productivity, we should talk about the challenges in the software development in general to understand how serverless may help us. And I refer to this wonderful book, Team Topologies, which has been released 1 year ago, and they are talking about the cognitive load. And the cognitive load is the total amount of mental effort being used in the working memory for software projects. And then they differentiate between intrinsic, extraneous, and germane cognitive load. And we'll go briefly over 3 of them. So intrinsic is how to write Java class, so use some framework like Spring, unit test, and so on. So our daily business. The extraneous is much more complicated. It's about how to make all different kinds of tests. It's about how to build, package, deploy, and run your application. It's also about configuring the whole observability stuff, like monitoring, alerting, logic tracing, and also auto-scaling. How to operate and maintain infrastructure in general. So we are not talking about how can a cloud help us there, but generally we have to deal with all these things. How to build fault-tolerant systems and resiliency, and just how to make hardware networking and application secure. And security is job number 1. So before we release everything, we have to deal with all this kind of stuff. And just in the world of distributing programming, all these aspects are very, very important. And also germane cognitive load is just our core domains like domain knowledge, payment, e-commerce. In case of ip.labs, this is how to build the editors. Today can you design your products, and also business processes and workflows. So just in general, with intrinsic cognitive load, we should become fluent in it. Just it's our daily business. We cannot outsource this. But in extraneous, it's such a huge part that our goal should be minimizing what we implement, operate, support all by ourselves, because it's a huge area. And germane, it's about the focus on our core domains of our business value, and every system will probably have e-commerce, but it doesn't mean that it's your core, and probably you should buy software as a service for this. So just you see a lot of challenges just before releasing something. When we are talking about productivity, the productivity as a term, we are productive if we regularly ship products. So probably products is from the productivity. Of course, they should be successfully used by our customers. And the question is, what's holding us back from being productive? And I refer to the survey, and you will see the links below to all material I'm talking about, and I will release all the slides. And you see that there is the report about the cost of poor quality of the software, and just this refers to how not to be productive, so to say. And you see the technical depth is probably one of the biggest parts. And if you look at the Wikipedia, you see the explanation of technical depth. It reflects the cost of some solution which is not the best solution currently, and you should then correct this with time. And this definition made me stuck, because in my opinion, and with my experience, technical depth, even a perfect solution today can become the technical depth over time. And it happens because if you select the newest version of our programming language, it will be out of support some years later, and probably the newest version will be not backward compatible to the oldest one. So just JavaScript frameworks are the best examples for this. And also security consideration can force us to upgrade, just like TLS 1.0, 1.1, just out of date, deprecated, and it forces us to use the newest versions which support TLS 1.2 and so on, the versions of also applications or web application servers and so on, which support this new standards. And it may also force you to use the newest version of your programming language. So the whole lot of dependencies there to technical debt. And also we have dependencies to open source project. They may be discontinued and so on. So we have to take care of rewriting the stuff when you're using the alternatives for this. So in my opinion, this technical debt is just everything which may happen to your software over the entire life cycle of your product. In the entire life cycle, maybe even forever. So just you have to think about this and have to think about how to lower this. And of course, is technical debt then related to amount of code written? So the more code you have to support, the more technical debt will occur. And also related to amount of dependencies used. So all the kinds of dependencies, open source project, programming languages, database, drivers, web application servers, these are all dependencies. If you are taking care of this, then it may become technical debt. So technical debt is one area which leads to less productivity. Another one is legacy systems. And for me, legacy systems are systems that can't evolve. And evolutionary architecture is from evolving. And I refer to another brilliant book, Building Evolutionary Architectures, from the people who work at ThoughtWorks. And then they are talking about how to build all those evolutionary architectures. They are talking about incremental change. So your architecture has to support incremental change, about the appropriate architectural coupling, and also about the fitness functions. And fitness functions, everybody uses them, we know them. Just this are code, source code metrics like cyclomatic complexity, all kinds of tests like unit tests and so on, performance metrics, also security like S3 buckets encrypted, key rotations, secret manager, and so on. And of course, all kinds of CI/CD tools like code commit, code deploy on AWS or Jenkins. So all these tools help us to move forward and check that we don't break something. And so we can get the feedback from the system from various aspects. So we've talked about technical debt and evolutionary architectures, which are very, very important to be productive, to become faster. And then we go to serverless, and then we will look out how it may help us. So we will be talking about the value proposition of serverless. And just if we are talking about value proposition, we should talk about the total cost of ownership for the serverless paradigm of architecture. So, and it starts with no infrastructure operation and maintenance. And ask yourself, for your company, is infrastructure maintenance and operation your core competency? If you are working for the cloud provider or data center, that's probably true. And otherwise, it's of course, it's the necessity to take care of this, but it's probably not your core. The next thing is how to build auto-scaling and fault tolerance. And just the question you should ask yourself, can you get capacity planning and auto-scaling right? And do you want to solve the hard problem of the fault tolerance by yourself? And you see from this report, the third area which prevents us from being productive are losses from the software failures. And of course, it may be buggy software, but it's also about not appropriate scaling when it should scale. And just capacity planning is really tricky. We at ip.labs have a lot of spikes in the Christmas business, which will come in 4 or 5 weeks, because just people preparing their gifts like the photo book of the year, and we have 10x and more peaks, and just the capacity planning is really pain. So just outsource this to the serverless ecosystem, to the cloud provider, is a really good thing. And just the kind of all the stuff with fault tolerance, with availability zones and so on, just it's really impossible to take care about this. If you have data center, you have to think about active, and so on, and just it's wasting time and money in the most cases. Another thing is what you can do with serverless, you can do more with less. And by this, I mean, Just by relying on the managed serverless services, you simply need fewer engineers to start implementing some kind of new idea. And what I see at ip.labs, it takes even days or several weeks for proof of concept and for prototyping. And also by relying on managed services, you can do simply more with the same amount of people. So you can keep focus. And also what you can get with serverless is lower technical debt. And we talked about this, that's just the huge area which prevents us of being productive. And I really like this quote from Paul Johnson, who is really well known in this serverless community. Whatever code you write today, it's always your tomorrow's technical debt. And it's really true. Everything will become technical debt, and also less code means lower technical debt. But also think that the configuration as a code is also part of the code. So everything that you ship together, it's also part of the code. And think about this way. Ask yourself what time and effort you require to build the solution and then to maintain this. In my experience, you spend 75% of your time maintaining the solution over the whole life cycle. And just implementation is only the small part of it. So you should think about maintainability or evolutionability in this case. And just in case if you rely on all these managed services, you can focus on business value and innovation, and probably every organization wants exactly this. So just everybody's crying they want to be innovative. And just this will enable you faster time to market, and time to market is the key differentiator in the today's business. So but you also have to ask yourself, what is your core and what is commodity and utility, and you can get this as a software as a service, just because that's the core for somebody else. So just talking about serverless mindset, and this is how we do this at ip.labs, just we think about this as an operational construct. So we strive to be on the right side of this graph. So the serverless first mindset is asking yourself, can I build with the completely serverless services like Lambda, DynamoDB, S3 where I don't manage anything from the infrastructural point of view? And if there are really limitations and we can't accomplish something, then we can go upstairs and then ask yourself, okay, can we do this with Fargate or Aurora Serverless there can manage a bit, and so on. So just that means serverless mindset for me and also for the company where I'm currently working in. But generally speaking, from the manager point of view, serverless or not, it doesn't matter. So the question is how I can measure that I'm successful with it doesn't matter what I'm doing. And that's probably the last book I will recommend, but this is probably the most profound book I've read about the software engineering. This is the book Accelerate from Nicole Forsgren, Jess Humble, and Jen Kin. And what they introduce are the 4 key metrics. And these metrics will be divided between metrics for the speed. This is deployment frequency, how often you deploy, and also lead time to changes, the time from the commit to the go live, and also about the quality metrics, like time to restore a service, how much time does it take if something bad happens that I can restore either automatically or I fix the bug and then redeploy. And also change failure rates, or how much, in what cases I'm deploying something which doesn't work properly. And you see 2 metrics for the velocity and 2 metrics for the quality. And what they say that the companies which strive to be high performant or even elite, they can combine those two. So that doesn't mean if you go quickly, then you have less quality. So it's about the best practices to accomplish both. And they also release DevOps reports since 6 years, and just what they do, they show what are the software delivery and operational performance best practices which can support you being in the high or elite space for quality and speed. And you see the cloud, probably the obvious thing which can accelerate the things. You see code maintainability, and you currently know evolutionability, how serverless can help you by outsourcing the things to the cloud provider. They are also talking about loosely coupled architecture, and serverless architecture are generally loosely coupled, event-driven. And there are a lot of other stuff like disaster recovery, chaos engineering, automate everything, and so on. So just all these best practices to become productive with serverless or even cloud in general. So just invest in all these best practices and also measure these key 4 key metrics just to see how serverless accelerates and helps you. Generally, several examples on the AWS, for example, time to restore service. So how you can restore automatically, and probably you know the strategies, blue-green deployment, there you have generally 2 copies of your stack, and then just you can switch back in case you see something bad happens. So just this A or B choice, and you have canary deployment. So you can do 10% traffic for the newer version and then observe if there are no failures, then you can switch more traffic, and then sometimes later you figure out, okay, can completely go to the newest version. And you can accomplish this with the serverless services at AWS like Lambda and API Gateway with API Gateway stage variables and Lambda aliases. You can do alias traffic shifting, like you can say point from my API Gateway for 5% of the traffic to some specific version of the Lambda. So you see in this case 5% for the Lambda version number 6. And then if you don't see any failures in production, then you can point this for all the traffic, and it works. These strategies are also supported if you do it with serverless application framework with SAM. You can select between all at once, which is, yeah, I go completely to the newer version, or between linear, so you go 10% or 10% over X minutes linear until you achieve 10%, or you can do canary by 10% over X minutes and then switch completely. And of course, you can define alarms, which will prevent go further and will enable you to completely roll back automatically in case some of your alarms will be triggered. So very, very powerful tools to which enable you automatic reduce time to restore service. There is also another very important metric, and this is time spent. And that's important is that you see that even the most successful companies, they only spend 50% of the time developing something new. And they also spend a lot of time for unplanned work and rework. And for me, unplanned work and rework is re-architecturing. So probably your architecture is not evolutionary enough. So in case of new requests, you have to probably refactor something and so on. And it doesn't really, so probably your architecture is not that flexible that you refactor all the time. And of course, everybody is working on remediating security issues and defects and so on. But just to be quicker, you have to, you have to rely on these managed services, and just they will give you the flexibility to work on the new stuff more. What's really interesting is this kind of Wardley diagrams. I don't have time to dive deeper on this, but what Simon Wardley says, who is the creator of the Wardley maps, that every evolution goes from genesis over custom built and community, commodity and utility. And function as a service, like Lambda or Azure functions and so on, they are already in the commodity space. So nobody has to implement their own function as a service solution. But in order to be successful with this, you have to apply kind of a co-evolution of practices, to be productive. This is very intuitive, so you can be successful with NoSQL databases if you do this like just for relational database. So you have some kind of co-evolution of practices. And this is my experience. These are the co-evolution of practices for the serverless development. So the first one, and I refer this to the DevOps topologies, which comes from the same people who wrote the book Team Topologies, and they are talking about best practices adopting DevOps, and also about anti-pattern. And what really works well in the serverless space is fully shared ops responsibilities between ops and dev. So they should be in the one team, and everybody should take multiple roles. So no DevOps team, no ops team as a separate unit. It simply doesn't work. And of course, if you go serverless, then if you have classic operational people, which worked in the data center, they probably won't be very happy because just no servers, no agents to install. And so they're asking themselves, what are the challenges? And interestingly, Charity Measures, who is very known in this observability space, he advocates even if you go serverless for the observability team or just kind of community of practice, because even if you're using the tools, they provide some kind of metrics off the shelf and alarms off the shelf, and then probably you know your software better, you know what metrics are really valuable. You don't want to pay for the metrics which you don't really need. And also, you know what services are the hottest one, and probably you should define the alarms also for them and not for some kind of asynchronous bad jobs. And so she sees the job of this observability team for defining meaningful dashboards, for defining meaningful alarms and so on. It may also work within the teams, but this observability topic is really, really broad topic. So developers should understand observability in order also to write good code with serverless. I also refer to another talk by Tom McLaughlin, who worked in the operational space and then went to the serverless space, and he gave the talk, what do we do when the server goes away? And he talks there about the whole monitoring and alerting. That's also the part of observability, because probably your application won't be completely serverless. So you have probably just other parts, but you have to provide monitoring and alerting for the whole application. It's also about chaos engineering and game days. The operational people may be in charge, and also about the testing of the infrastructure as code, because even this may break. And another area which might be even more important, it's understand constraints and trade-offs of different AWS services, serverless services. And one example of this, just in case of event sources, we have multiple choices like Kinesis Stream, SNS, SQS, even event bridge, or even the combination of them. So how to select the appropriate solution for now and for some years for the future, and not to revisit it day after. And you have to understand how they scale, how they're priced. And in case of event sources, you see if you have only one message per month, then probably you see that Kinesis is the most expensive one. But if you have 1,000 messages instead of one message per second, then we have another picture. So Kinesis will be the cheapest one, because SNS and SQS scale per message, and also will be priced per message. So just, I think that the operational people, they are very sensible about these constraints, how they scale, how they will be priced, because they did this in the data center for the EC2 instances, for the storage, and also for the databases. And they can help developers to meet the right decision from the beginning. Of course, if you are very successful, you should revisit your decisions with the time, but generally it's important also to start the right way. So other best practices is also FinDev responsibilities in the team. And you should be, your developers or your team should be allowed to look at your bill. So the pricing is like the feature, like the performance, security, and so on. And if you see the services which costs you a lot, so you have to propose the improvement, because there are a lot of choices in AWS which may make this cheaper. And also there is kind of FinDev concept that what you can do with serverless is to put the price on features and also on the transactions and so on, and see what value delivers some specific features and how much is it priced for your customers. And you may figure out that you have features that you will give for free, but they cost you a fortune. So this is kind of a very powerful concept, how with the serverless that you can price your features, your services accordingly, and see also AWS bill, and also total cost of ownership. So FinDev is also important. And they have another stuff, complete infrastructure automation. This is completely true for the serverless development, and also chaos engineering, where operational people may be in charge. And what I also see that the serverless each developer may have its own test account or staging account, and even account per feature or service, because it's really that cheap to have these accounts, because with serverless you pay as you go and you don't have too much storage capacity there. And also what I see that there is no very little local testing environments, or only for quick functional tests, because it's very difficult to mock all the permission stuff locally. So people tend to test in the real AWS environments, and with the serverless, it's really a perfect solution. But of course, you have to consider testing in production, because the real user behavior you will only experience in the production. So just testing test environment, it's really good for some specific kind of tests, but a real production, it can't replace real production. So what you will get with the serverless ecosystem, so with the right engineering practices in place, and you should look at those metrics from DevOps report and adopt them, you will significantly reduce extraneous and germane load by relying on managed services. And you will also reduce the amount of dependencies, because you are not managing like web application server or the runtime of your programming language. And you will also reduce the amount of code written. And I would like to explore this further. So how you can reduce your code with serverless ecosystem at AWS. And just there are 3 areas how you can do this. Write fewer Lambda functions, also write less infrastructure as a code, and also use frameworks like serverless framework, which provide meaningful abstraction. There is intersection between these 3, but generally we will be talking about this. So with writing less Lambda functions, there are a lot of direct AWS service integrations, so you can rely on them and don't write Lambda function. And if you less Lambda function also means you write less code, you test less code, and you also run and maintain less code. And also you have less CI/CD pipelines to maintain. You also have less infrastructure as code, policies, permissions, and so on to maintain. Also, you have less cold start worries, because that's a kind of pain point for Lambda. You also have less points of failures and retries, because Lambda function can fail all the time and maybe retried, and even maybe automatically retried. You have less security concerns by shipping less code. And of course, you have less worries about Lambda limits, like concurrency setting per account, like 3,000 Lambda executions in parallel for one account. So by writing less functions, you eliminate also some of these concerns, and also spending on Lambda will be less, and also then CloudWatch spending. And if you use a third-party observability tools, they rely on the Lambda invocation sometimes. So just you also lower your bill. Just writing less infrastructure and code, it's not only applied to Lambda, but also you will be talking about services like AppSync, which generate a lot of client code for us, and we don't have to write infrastructure as code to this. And also about providing meaningful abstractions like Amplify frameworks or serverless framework components. So now we will dive deep in some of these services. Just to give you an overview, we'll be talking about just all the stuff. And the first one, as already mentioned, the API gateway service integration. So you can integrate an API gateway with SQS, DynamoDB S3 directly without writing your custom code. And one example is, which we use at ip.labs, is DynamoDB sequence generator. So we have the products, groups, and so on, and we would like to generate the IDs for this. And that's the perfect scenario for not writing the Lambda, so just connecting Amazon API gateway with DynamoDB directly. And it works by providing VTL template, where we simply give the command to DynamoDB to update the sequence and return this sequence. So Shin Brizzles wrote also the post about this, how to accomplish this. You see that we simply integrate API gateway with DynamoDB and use update item action. So very, very powerful concept. And also you have HTTP API. This is kind of alternative to the API gateway. Now you have storage first service integration. You can do this with event bridge, Kinesis, SQS, app config, and step functions. So without writing any code, you have also step function direct integration. Many people don't know that you can integrate a step function with SQS, SNS, and even with DynamoDB without writing lambdas. So also very powerful. Another architectural pattern is using event bridge filtering. And you can send the event to event bridge, and then you can filter this to so that the listeners only get them process the message if the filter applies. So you don't need to use fan out pattern with SNS and then send this to multiple providers. So you can filter on the event bridge itself. It also saves a lot of code. For this purpose, you also have Lambda destination, so you can connect your Lambda with SNS, SQS, with even dead letter queue as SNS in case your Lambda return the success results, so 200 HTTP code on in case of failure. Previously, you had to write this code in your Lambda, so in case of HTTP code 500, then send my message to SQS and SNS. This is currently only the matter of configuration, and this allows you to send the failure, for example, to SQS dead letter queue. This was released this week, so you can now export DynamoDB table directly to S3 data lake. And previously, if you wanted to accomplish this task, you had to write AWS data pipeline or set up Amazon EMR cluster and so on, and you had to scale this. Now you can completely rely on this feature and also save the code and time. And there are other examples like AppSync is just managed GraphQL, and you there have the Lambda resolvers and so on. And this also gives you the opportunity to save on code, to save on infrastructure as code, because all this logic for connecting your storage like DynamoDB or other database like Aurora will be generated for you. Or you can even use Amplify framework for this purpose. There a lot of code will be generated on the client side, and Amplify, you can use AppSync under the hood if you will, and it also saves you on Lambda functions, on client side code, and infrastructure as code. The same is true also for the Serverless framework. It's an open source framework, and there is Serverless framework components, which provides you like building blocks which you can reuse, and just then you also reusing the infrastructure as a code which comes with these components. So just a lot of architectural best practices which help you reduce amount of code which you can do with AWS. It's probably the whole topic for the talk itself. So serverless with focus on your core domain will enable you iterative development mindset. It's really important for the evolutionary architecture. It also enables you experimentation culture. It's also important for the startups and so on. Try out features quickly and cheaply as possible, and also enables you focus on the business value in innovation. And of course, it enables you evolutionary architectures. And we've been talking about how important this is. Interestingly, that the authors of this book, they also wrote the article about different architectural styles, event source, just microservices, serverless, and what they write there, that serverless ecosystem supports evolutionary architectures really well. But what they also say, that all serverless solutions often suffer from anti-pattern last 10% trap. And this is if you can do 19% very quickly, and then you just got stuck for the last 10%. And this, I had this feeling probably several years ago working for serverless, but just with a lot of new features or new services which AWS released in the last months or years, they really improved the situation that I really can say that you can accomplish a lot with serverless. And we will only briefly mention some of these major improvements because there are a lot of them. Just shared file system, elastic file system for your Lambda enables you to use machine learning and artificial intelligence, because elastic file system speaks NFS dialect like normal storage, so you can install the normal programs there, which is not possible on S3. So this is the door opener for TensorFlow and so on, for video processing and so on. Also, provision concurrency enables you to have warm containers in case you need a lot of them, so kind of pre-provisioning. And also the door opener for the programming languages like Java, they suffer from the higher cold start. HTTP APIs in beta provides alternative to API gateway, and it will be 70% cheaper and also faster. There is no feature parity currently, but they strive for this. And just API gateway may be very pricey if you have millions requests per minute and something like this. Also, DynamoDB. Yeah.
Sorry, Vadym, I just wanted to see if there were any questions. We've got about 5-6 minutes left to this presentation. And so I just wanted to make sure people got their questions in. So please put them in, to the Q&A section. And then after the event, you can meet with Vadym and the join face-to-face. So sorry, didn't mean to interrupt. I just want to make sure I got that in.
Everything all right. I need 5 minutes, so just I will finish on time. So just DynamoDB on-demand capacity, which was released 1 year ago, I think. Just previously you had to deal with write and read capacity units, and just as like provisioning the servers. With on-demand capacity, you can offload also this work. So a lot of improvements from AWS. Also, the situation that you have to put your Lambda behind the VPC if you use Elastic Cache, Elasticsearch, and RDS, just with one exception with Aurora Serverless Data API. We had additional cold start time for about 10 seconds, and it has been improved last year. Now you have only maximal 1 second of cold time. So just a lot of improvements. Also, Amazon Aurora Serverless Data API, which allows you to access your relational database over HTTP, like you do with DynamoDB, and you don't manage your data sources and so on, which is really not very good situation with Lambda managing the data source and caching your connection and so on. Also RDS proxy. So just a lot of improvements which make serverless ecosystem even stronger. And also CloudWatch had a lot of features added, like searching over multiple log groups. Also CloudWatch Insights enables you interactive research and analyze your logs, and also embedded metric format that you can stream your logs to the CloudWatch asynchronously. So even CloudWatch, a lot of very valuable improvements. But just some improvements which I may suggest from my perspective, which will make the serverless ecosystem even stronger on AWS. Just elastic file system for Lambda is an important step, but it's there are a lot of features which I really miss if I compare this to S3. So I cannot do anything like in case of creating files on elastic file system, which works with S3, and also all the stuff with compliance and governance, which really integrates well with S3 and AWS config and CloudTrain. It's currently not possible with elastic file system, but it will be very useful. Also, other CloudWatch improvements. It's currently not a match for third-party observability tools like Lumiga, Hexagon, also Thundra, and so on, in case of alarms, PagerDuty. So CloudWatch provides really basic functionality for observability and logging. But if you do things at scale, you will probably need other tools to support this. And also, many people really don't use code commit because it's a basic service. They use code deploy, and they're accustomed to use Bitbucket and GitHub, and just I think also code commit has to become better for PRs and so on, automatic notification in case of review is done. So just a lot of missing features currently in this space. And also X-ray support for the observability is a really nice thing, but sometimes the new serverless services will be released and it's missing support for the X-ray, and so you see gaps in your observability map, and event breaches one of these services. So AppSync now supports X-ray, and the same was true for SNS and SQS, but I think that X-ray support should come with the day one if a new service is released. So to wrap up, we've talked about all this technical depth, evolutionary architectures, legacy stuff, and so how serverless may help us by outsourcing all the things. We also have talked about different architectural patterns or services which may help us to reduce the amount of code written. And it's really important because the more code we have, the more technical depth we will have. We'll also talk about new services which close the gap with this 10% anti-pattern, and I finished the talk with some suggestions how to improve the serverless ecosystem. So I hope that you found this talk useful and may apply the things that you've learned, and I will be happy to answer your questions now with face-to-face. So I will leave this presentation and go to Jitsi. Thank you very much.